so much for the topic actually is quantum computing as an uprising topic for business students in higher educational institutions. So, okay, this is, um, change.
It's the fiction. He doesn't like when I.
No. Okay, now it's okay. So this is the content of my presentation. I will take you through the background of our study. Then I will mention our research objectives, then the methodology that we adopted in this study, and move on to the results and discussion, and then give you some of the recommendations that we made, and end the presentation by giving a conclusion and also mentioning some areas for further research. So starting with the background. So it's first of all important to know what's quantum computing all about. It's actually a new technology for computation that leverages the law of quantum physics in order to provide exponential performance for some applications. Quantum computing is said to have some to be disruptive in certain businesses and also industries, and it is projected to have an economic value of up to $1.3 trillion by 2035. There are lots of investments going on in this technology, both from the public side and also from the private sector. Despite this economic value that quantum computing is said to have, there are two main problems. First, there is a lack of sufficient expertise in this field. And secondly, quantum computing education is mainly tailored towards technical students. So students that are non-technical are actually ignored, so the business students. With these two problems in mind, we set out to meet the following research objectives. So the first objective that we aimed at achieving was to highlight the relevance of quantum computing in business. And this objective was attained by showing how quantum computing is currently applied in certain sectors. And our second objective was to identify the gap in quantum computing education for business studies. And here we met this objective by showing the current state of quantum computing in education. And our last objective is was to highlight the barriers to the adoption of quantum computing in the business domain and also in education. So how did we actually meet these objectives? First, we have adopted a structured literature review approach. And with this method, we actually use keywords such as quantum computing cause, or barriers to quantum computing adoption on platforms such as Google Scholar, Science Direct, IEE, just to name a few, in order to extract relevant papers. And with this, from these relevant papers, we could find relevant information to meet our objectives. We have actually also complemented our study with a survey that was done at the University of Applied Sciences, precisely the School of Business in Basel, Switzerland. And this I will be presenting to you as well. So let's move on now to our result. So as I mentioned, the first objective was what is the relevance of quantum computing in business? And we have made this by looking at quantum computing applications in sectors such as financial services, agriculture, and ecology. Now, starting with financial services, and here some authors like Orus et al. And even Deloitte, which is an industry player, have mentioned that quantum computing could solve supply chain management problems. It could also enhance dynamic portfolios and even credit scores. But there is a diverse effect. There is a risk to cybersecurity. So what does this mean? Quantum computing could actually render current cryptography obsolete. What these authors are actually recommending to organizations in the finance sector is that they need to enhance the trustworthiness of their services in order to combat against these emerging threats. Now, going on to the agricultural sector, there are authors such as Marvis et al. That have mentioned the potential of quantum computing to positively influence farm practices and also to increase crop yields. However, there is a problem. These authors have mentioned that quantum computing in quantum computing there is need for hardware, so different organizations will need to compete for hardware in this field, and there is also lack of expertise. And the last sector that we looked at in order to answer the question of what is the relevance of quantum computing in business is ecology. And there again, we are seeing that some authors like Bruno, even PwC and Deloitte have highlighted that quantum computing could actually solve ecological problems. It could enhance ecological models and even enhance the readiness of fundamental approaches to quantitative ecology. Now, let's move on to the second objective. And remember, the second objective is what is the gap in quantum computing education for business students or for in business studies. And here we went on to look at what have other authors written about quantum computing tailored towards non-technical students. And the first author, for example, the first authors include Saheli et al. In their study, they carried out 22 workshops in different countries, and they have seen that the main challenge is understanding quantum computing. So it's difficult for non-technical students to understand what quantum computing is all about. And what they recommend from their study is to eliminate complex numbers when introducing quantum computing to students of non-technical background. And they saw that by eliminating these complex numbers in teaching quantum computing, it increased the understanding of the students. Sad et al. Also mentioned in their study, so their study was all about introducing quantum computing to undergraduate level students, and they saw that these students had a difficulty to actually grasp the fundamentals of quantum computing. And they are recommending the need to adopt an approachable manner when teaching quantum computing to students, especially those of non-technical backgrounds. Tucker in their study tried to introduce quantum computing to high school students. And then they still saw that it's very difficult for these students to grasp an understanding of what the course is all about. And they actually said adopting a self-directed learning approach would even add to the complexity for these non-technical students. And lastly, in Angela et al., when they did a research of how to introduce quantum computing to students of non-technical background, what they are recommending is when you're introducing such a course, adopt the course as a workshop, bring in diverse participants of different age groups and ensure that there is interactions between the different participants. By so doing, there is a high probability to retain the student interest and to increase engagement in the class. Now, I mentioned that we have complemented our research with a survey that was done at the University of Applied Sciences and precisely at the School of Business. 78 participants actually completed the survey, and these were students from different business programs. And the aim of the survey was to find out how can a quantum computing course be introduced to business students, and also do the students actually have a prior knowledge of quantum computing, and what do they think is the importance of quantum computing for their own development. And our findings include that 68% of the participants do not have a prior knowledge of quantum computing. 60% do not actually recognize the importance of quantum computing to their development. However, 67% of the business students that completed our survey mentions that they would be interested to learn about quantum computing. So this left us thinking, if there are business students that want to learn about quantum computing, what is currently out there for the students? What are the current quantum computing offers to business students? So we went out searching to know quantum computing programs tailored specifically to business students, and we saw that it's missing. So there is a limited options for quantum computing offers for whether bachelor student or master's level students. And this is also in line with a study that was done by Plunkett et al. In 2020 in the US. So they collected a range of offers of quantum computing programs, and they saw that most of these programs, if not all, were actually tailored for physics and engineering students. So business students are actually left out when it comes to quantum computing education. However, online platforms like LinkedIn and Udemy, they offer some beginner level courses, which non-technical students, bachelor level students can also enroll. And these courses do not need a prior knowledge in quantum computing. And industry companies such as IBM and CERN, they also offer beginner level courses. And our last objective is the barriers to the adoption of quantum computing in business and also in education. And focusing on in business, so we see authors like Basne and even Avane, they commonly highlighted that the main challenge to the adoption of quantum computing in business fields remain the lack of expertise. So why is this a problem? So quantum computing is a very specialized field requiring some special skills. And this is difficult to actually attain or to get. Another challenge remains the fact that there is a lack of an ecosystem for co-creation. So quantum computing is still a developing technology, and building an ecosystem to foster co-creation takes time. So, but this is a challenge as to why businesses are not rapidly adopting the technology. And there is also a limited understanding of market demands around this technology, and this limits the businesses' willingness to quickly adopt quantum computing. Moving on to the educational domain, here we see authors like Kabiri R mentions that the complexity of the course. So remember when I was presenting before, like students kind of shy away from this course due to its difficulty, and they need to understand courses like quantum physics and chemistry. So this will be very difficult for business students or non-technical students to grasp. Another challenge is the fact that there are lack of existing use cases that businesses could or educational institutions could use to introduce the course to their students. And again, it boils down to the fact that the technology is still in its developing stage, it's still in its nascent stage. Time constraint is also another hindrance. So institutions do not really have time to teach both the practical side and also the theoretical side. And lastly, budget constraints remain a challenge. And this goes in line with what I mentioned before, lack of expertise. So they do not have enough money or a big budget to hire the right experts to transmit the knowledge of quantum computing to their business students. Now, considering these barriers to quantum computing adoption in business and also in education, and also considering that quantum computing is of relevance, what are we recommending in our study? So we underline the fact that quantum computing should be introduced to business students. And why we are actually highlighting this is because business students could actually support in making informed investment decisions. So if they can understand this technology or the basics of it, then they can support co-creation or building business models around the technology. So they are actually needed. And for this reason, we are recommending that educational institutions where quantum computing is currently not being offered to their business students, they could encourage their students to enroll on online programs offering quantum computing for beginner level. So Udemy, LinkedIn Learning, or Coursera. We also recommend that running a quantum computing course as a workshop, short-term workshop, could also be of benefit. And we've seen the first-hand experience at our university. We ran like a short-term workshop, and we could easily manage the interest of the students and keep them focused. So having it as a short-term workshop would be of benefit. And then adopting teaching models like practical cases encouraging interaction between the different participants could also enhance the interest of the students in such a course. To conclude, investments in quantum computing reflect the optimism of investors in the technology. It shows the potential of quantum computing. The barriers to the adoption of quantum computing in business actually relate to those in education. For example, this lack of expertise, it is actually a hindrance to the business side and also to the educational side. However, it's really important to incorporate business studies in order to enhance informed investment decisions making. Now, we have contributed to the discussion of quantum computing in business and especially in education. However, we are still encouraging further research to be done in this topic in order to understand how to integrate quantum computing in business studies. And we also encourage future researchers to bring in quantum computing experts to interview with them. This is something we have not done, to actually find out how can a quantum computing course be modeled specifically for business students. This brings me to the end of my presentation. Thank you for your attention.
Thank you very much. Thank you.
Okay.
But you still have time on how to do this.
Yes.